I need this. Okay, first we'll define the average acceleration. Average acceleration, how we define this as like a change in velocity by time taken. So this will become A average is equal to delta V bar by delta T. Change in velocity is telling altogether. Okay, this you can write it as V2 bar minus V1 bar by delta T. A body is said to have, it's like how you define average acceleration, change in velocity by time taken. So there's a basic definition of the average acceleration. So it's telling change in velocity. So velocity is having two quantities, no? It's having the speed as well as direction. So which quantity, due to which quantity changes the body's side to back acceleration? Any one or both. So first example, we take it. A body is said to be accelerated. A body is said to be accelerated. First case, if speed changes. So what do you mean by speed changes? So there's an example, I'll give it. Okay, look at the speed of the body. It is moving with 40 kilometer per hour, or say like 20 kilometer per hour. Now it is moving with 30 kilometer per hour. So shall we say that it is accelerating? Now in what action that acceleration I should represent? V2 minus V1, and it will take, let's say that it will take a time of say like 0.1 hour. In what interval of time the speed changes by from 30 to this one? So then can we show that average acceleration? It will be in this direction. And why it should be directed? Because V2 minus V1 change final minus initial. So how to calculate that one? A average is equal to V2 bar is how much? 30 I cap kilometer per hour. This will be 20 kilometer, 20 I cap kilometer per hour by what is the time? 0.1 hour. So 30 minus 10, 10, this will become how much acceleration? 100 kilometer per hour square. If you want to convert in meter per second square, convert it. So usually what is the typical unit for acceleration will be meter per second square. Or we do write like this. So I'm expressing in terms of kilometer, or if you want, you can convert it. Or instead of 20 kilometer, no, you write 20 kilometer per second. It will be much easier for you. This hours I'm finding difficult. Okay, change this. This will be, it's left to you. And let it take say like around 10 seconds. Nowadays we do have such a bikes, no, where you can change speed instantaneously. So this will become now kilometer. I'll take it out. I'm showing either of things. 10. So this should be equal to how much here? 1 meter per second square. This will be the acceleration. What about the direction? 1 I cap meter per second square. Look at the direction of average acceleration will be in the direction of increasing speed. Why it will be in the direction of increasing speed? According to the definition, V2 is greater than V1. So therefore, average acceleration will be in the direction of this one. So if a speed of a body increases, in what direction the acceleration be directed? In the direction of increasing speed. So that's why the acceleration is said to be directed towards right. Got it now? Now there's about first thing. Later on I'll come in detail. If speed changes. Next, third thing, if direction changes. If only speed changes, we'll write it. If only direction changes. How come if there's a change in direction, there can be this one. So the bike initially it was moving along x-axis, we'll say it. Then afterwards, so there's a road here. I think I'm able to show this much like this rough diagram. So we have a road. He was moving along a positive x-axis. Then afterwards, he'll change his direction. This is x-axis. This will be y-axis. He was moving with a speed, say v. So what is that v? So let it be 10 meters per second. So what is the time he will take to change the direction of motion? Let it be 2 seconds. Within 2 seconds, he'll take a turn. Let's see that how that acceleration will be directed. So what is our basic definition? So this will be v1. This will be v2. v1 equal to v2 equal to how much? It is equal to 10 meters per second. Only direction of motion changed. It was moving along positive x-axis. Then you'll take a turn. The bike will start moving like this. The bike will start moving like this. So what is the like a speed? The speed of the bike remains same. Only the direction changes. So strictly I'll write it. Speed of the bike remains same. Only direction changes. Okay, due to this, will there be any acceleration? Yes, there is an acceleration. So let me stick on to that one. Average acceleration equal to V2 bar minus V1 bar by delta T. What is V2 bar? V2 Vj cap or V2 J cap timing, let me write. Minus of this will be V1 I cap delta T. So what is V2? 10 J cap minus 10 I cap. Delta T is how much? 2 seconds. So this will become minus 5 I cap what direction it will be directed? Minus 5 I cap plus 5 J cap. The average acceleration, it will be directed here. So therefore here, that particular direction I'm going to indicate like this. E is said to have now acceleration in this direction. The second case we are discussing, please do notice. First case in what direction average acceleration? It was in the direction of motion. No, not in the direction of motion. So what is this acceleration? This acceleration is due to change in direction of motion and it will be directed in this way. What is the magnitude of acceleration? How to calculate? Minus 5 I square plus 5 J cap whole square. So this should be equal to 25 plus 25, 5 root 2. And what about the direction? The direction will be, it will making an angle 45 degrees. Okay, now why this acceleration is due to change in direction of motion. So a body can get accelerated due to change in speed or due to change in direction of motion. If both take place, as if speed as well as the direction changes, the body is said to be having acceleration. That later on we are going to discuss in the curvilinear motion. So third case, I will not give any formulas here because this will come in curvilinear motion.